Ready? Just want to go through design exercise 3. Design exercise 3. Again, we continue with the same exercise of the toolkit. And what you require to do here now is provide the engineering drawings of the product itself. And so that's what it says here. So we have done all these components already. Now we need to do a drawing so that could go for fabrication. Or we could read, that is how drawing is how we relay our design to people, right? The machinists, the fabricators, etc. So this was our sketch that we did, and we had used to sketch for our calculation purposes. So now we could go on to the actual job. You would be using SolidWorks more than likely, right? I am using Autodesk Fusion 360. Right? The software is around the same. They basically do the same thing. So it works as a bit more functionality in terms of when putting together the drawings. Right, so this was our general design. Right, we have the two baskets here being hung. Now you could see that when we had assumed many calculations are uniformly distributed load, but in reality, what we have here is 4-point loads. Right, so that's how design is an iterative process. So after we come to this and we select our pipe size based on the calculations, then normally what we would do now, design engineers would come back now and say, okay, this is practically how we hang in the baskets. We would redesign it now for 4-point loads. Right, and see now if we will be able to withstand that load, and also now use that information to design these fittings here. Right? But we would just stick to one design iteration. That first round of calculations we did, that's good enough for now. Right, so in terms of the drawing, after you generate your 3D CAD drawing, right, so this here is the basket assembly by itself. Right, so we see we had some nuts and bolts. Right, so in SolidWorks would have similar insert component options just like this. So you could insert a component such as a nut, bolt from different manufacturers. Right, you just need to play around with SolidWorks and do some online searches, and it's very simple. Right, in Fusion, again, as I said, it's not so simple, and in SolidWorks it is a lot more simple. Right, so this is generally how the drawing is supposed to be like. Now, let's just break it down. Don't get too worried. We have the 3 views, right? Or in this case, 2 views is good enough. Front view, top view. And in this assembly drawing, so notice we say toolkit assembly below here. It shows the general dimensions. That is what your first drawing does, is you show the general dimensions, the width, the height, etc. Right? And then also now you begin to label the components that makes up the assembly. So that is what this do here. Now put an isometric drawing here so that you could, sometimes this might not be too clear to visualize. And the isometric drawing basically gives you a 3D representation of it, so you can actually see what's happening. Right, so we could see number 1 here. All these components are number 1. If you go to number 1, that's the bottom rod. The description is cut to length 625 millimeters. So remember, this was L was 0.6 meters, 600 millimeters, right? The extra 25 millimeters is to give it enough distance to go into the fitting. Right, so sound like what it has here. Right, part item 3 is the vertical rod. So we label all the components and we give the description here as to we cut in that 1825 millimeters. So based on your parts list, we could actually cut this and begin to assemble. And stuff that might be too small to see, we have a detail. Now these things are, again, once you do the drawing, you do your 3D CAD drawing, generating this 2-page drawing. It takes time, but it's simple. Right? Unfortunately, in Fusion, you can't change text size and stuff, so that's why the text are different sizes, and it's a bit messy. Again, in SolidWorks, you will not have that problem. Right? So elements that I will be looking for in grading is you must have your title block. So that's what highlighted here. Right? You must have your dimensions. You must have your parts list. You must have your title block. Right? Your title block will have the information that more or less that you're seeing here, including your scale. So if someone were to print this drawing on a size A page, what that means is that you could actually measure off and multiply it by 30 and get the actual dimensions. So you could put a ruler, measure from this distance to this distance, multiply by 30, and it should give you 1352. So that's the purpose of having the scale. You must have some notes. So in this case, there's some general notes. All rods are 1 inch schedule 40 pipe. The fittings are T-type and it's threaded. We're using caster wheels, and we had said any muff chart that we wanted manual braking, so there must be some brake levers so that we could lock the caster wheels in place. Alright, so this is revision 1. Remember I said that design process is normally an iterative thing, so this is just the first iteration again, which is good. We have the title of the drawing and the title or the name of the project itself. So the project is Toolcat, but the title is Toolcat Assembly. Right, so we notice now we don't have any detail on this basket. So that is a component detail, a component drawing. So on the next page here, so that's what I did here, a component drawing. So I detail the basket. So again, we have overall dimensions. We have a 3D representation of it. We have some detail, and then we have the parts list now that govern the tool basket assembly. So we have the hooks, washer, nuts, bolts, we have the actual basket, and then we describe what it is. M12 nut, M12 grade 8.8. So we will come to what grade 8.8 means when we do fasteners. M12 means it's a 12 millimeter bolt. Right, and then again for items that are too small, we zoom in here so we could see. We have some dimensions here, so where the hole must be in the basket for the bolt to go in, so we could, that is what this detail is about. Right, so unfortunately, Fusion doesn't give the flexibility when doing drawings like this. For example, ideally I would have liked to have the hooks, which is these components here, separated and dimensions separated. Right, so that because it's as simple, that could have actually fit in here and have some dimensions, but Fusion not giving me that option. So I had to dimension it here. Right, previously I used Autodesk Inventor, which gave me that option. Right, so SolidWorks should give you that option. And again, we have some notes. The basket, the material itself is made of 3 millimeter sheet, 1/8 inch that is. Then we have the hooks made from 5 millimeter flats, and this case I specify we use a plasma cut. Plasma cut is this plasma cutting machine that a lot of fabricators have, that people that make doors and windows and stuff now. People like QPSL, Kelvin and Sons. You know, this place by the Naga there's a big RDK, I think it is. So all these fabrication places that make doors and stuff, they do plasma cut. So that is what plasma cutting is. It's computer control, so your dimensions will be exact. Right? Dimensions to be confirmed by analysis. And number 3, analysis to confirm bolt size and dimensions given in detail B. So there's the bolt, M12 bolt, and then there's the hole. Now what this means here is that dimensions will be confirmed by analysis. In the calculation, all we did was calculations on the beams. We did not look into the strength of the hook, or if the hole is too big or too small, if it would tear, etc. So all we focus on in this project is the calculations of your beam aspects of your design. Right, the other part, the project 2, will focus more on detail of different components. So analysis would need to be done in reality of that component. Also now, analysis to confirm bolt size. So we say it's M12 bolt. So how we know is that 12 millimeter bolt? We need to do some analysis also to determine if the bolt could withstand that load. Right? And also the bolt to the edge of the box or of the basket is 15 millimeters, 15 millimeters. Right? So we have something called bearing strength. And what bearing strength is, it is really the strength involved in preventing the basket material from tearing away. So kind of like a file page in a folder. You know, you have the holes, and if you were to pull on the page, the paper would tear around the hole. So that is tearing strength or bearing strength. So there's a calculation that ensures that does not happen here. So the steel does not tear, the steel plate does not tear. Right, so again, we're looking at your border, parts list, title block, your different information as you see here in your title block, some notes to give a little description, um, point out that your dimensions are in millimeters. Right? And again, when we come to the project 2, in project 1, when grading project 1, I will highlight all what needs attention. So when it comes to project 2 now, you will be better equipped in giving an even better drawing or even better report, right? So again, if you have any questions, feel free to send me an email. And one of the advantage of virtual teaching is that if you're having some problems on SolidWorks or putting together your drawing and you want me to check something before, you could just have a Zoom call and you could share your screen and I could look at it and say, okay, yeah, you need this, you need that. This is not necessary. And so we could actually take advantage of this type of learning as much as we can. Right, so again, I will export these two documents to PDF and I'll include it on Canvas. And there are some projects that some students that like to put more than one drawings on one page. This in itself is one page. So don't try to squeeze two, don't try to print screen, export it to a PDF. And whatever the PDF size is, well then that's okay. You could actually add it to your report at the end. Okay, so